Okay, so if I get everybody to quiet down. So last week we were talking about revision control and Git. And I told you that the better type of revision control system, okay, guys, I need you to quiet down. I can't talk over all of you. I'm loud, but not that loud. Okay, thank you. Okay, so we talked about there were classically two kinds of version control, lock-based and merge-based. Merge-based is the modern type. Git is an example of a merge-based revision control system. Let me turn this down a bit. How's the volume in the back? Is it okay up there? Okay. Merge-based, basically, everybody can work on their working copy, their own local copy of the files at the same time, and it all gets sorted out when you put things back in the central repo. That's when it figures out who did what. So it just lets you work independently, and it gets put back together when you put it in the central repo. Okay, let's see how this solves our last problem, which we numbered problem 2, conflicting edits. Okay, so Tony Stark is working away. He's made some changes to this red file, and Bruce Wayne is working away, has made some changes to this green file. Okay, so Tony commits and then pushes. Use these two commands in sequence to publish your changes, send them into the repository. Okay, so now we've got a new revision 2, and notice it's got Tony's changes in it. It's got this red file. Okay, Bruce Wayne. So C09, I'm going to get you guys to quiet down. I'm going to pick on you. Thank you. Bruce Wayne wants to put his changes back. So he says, okay, I want to commit, I want to push, put this green file back. It's going to fail. Okay, it's going to fail with a somewhat cryptic message. It's going to say, can't do fast forward merge. Okay, what this message means, Git is smart. So Git actually knows that Bruce Wayne's files are based on revision 1. So it knows the last time he updated his files, he got revision 1. And he's made some changes since then. And when he does this commit and this push, Git can see, wait a sec, there's a revision 2. Your changes are not based on revision 2. Your changes are based off revision 1. Okay, so I don't like this. I don't quite know how to put your changes together with what's in the repo. So what he has to do is he has to get these changes from the repo, these changes that have been published by Tony Stark first, and bring them into his working copy. And he does that with a command called git pull. Okay, so put stuff in the central repository, and pull takes things out. Okay, so he does this pull. Now, we're specifying this -r option. I'll talk a little more about it at the end of the lecture. It's optional. If you don't specify that, it's okay. We recommend you use this -r option because it gives you essentially a cleaner list of revisions. But you don't have to use it. Nothing bad will happen if you don't. Okay, when we do that, what happens? Well, in Bruce Wayne's working copy, he gets the changes in the repository that have happened since he last took things out of the central repository. So he gets this red file, these red changes from revision 2, and they come into his working copy. Okay, and then Git updates his working copy to say, well, it's based on revision 2. So Git has some hidden data. So it says you're based on revision 2 now. Okay, so that's actually enough that he could now commit his changes and push his changes. Well, he could push his changes. Should he push his changes right now, or is there something else he should do first? What do you think? A09, I'm going to put you on the air here. What do you think he should do? Should he push his changes, or should he do something else?
You've got to test it first.
He should test it. That's exactly right. So it would be a bad thing for him to just push his changes. He should make sure that what he's got in his working copy works with these latest things. So he builds it, he tests it, it all passes. Now he can push his changes, okay? And it will work this time. And there'll be a new revision, revision 3, that has everything that was there before, the red file changes, and now his green file changes are in there too. Okay, so this is going to be kind of your existence in this course. You're going to go through the sequence of pulling down your teammates' changes, committing, and pushing your changes. So A09. Question? Yeah.
So what if, for example, okay, so what if Bruce Wayne is like, he's done the second file, right? So like, let's just say Tony Stark worked on the red one, and also, so the third one, I'll call it the third one, and the second one. He did changes on both.
So you're saying, what if he did some changes here too, which I can't highlight in red very well, but what if he made some other changes?
He made other, yeah, on the other file.
In the same file that Tony had changed, is that right? That's what you're saying?
Yeah, and so like he has the old revision, Tony has pushed the newer one, but if he pulls the newer one, then maybe his changes, Bruce's changes that he did in his own file.
Maybe his changes get lost or something bad happens. Yeah, so it's a great question, such a great question, it's on the next slide. So I'm gonna go on to it. Okay, so this case I showed you is kind of a nice happy case. Bruce and Tony are working on different files. You can see how these things can be put back together and there's no problems. Okay, what if they worked on the same file, which is I think exactly your question. So here notice that Tony has put back this red file. Okay, so he's commit and push to get this red change in. And Bruce Wayne is editing the same exact file, but he's made different changes, they're green. Now he tries to do this git and commit and push. Okay, we already know it's not gonna work, but we know what he should do. He should do a pull. Because he's gonna get told you can't do a fast forward merge, which is git speak for somebody else change something, do a pull. So he does this pull, and git is pretty smart. It won't lose your changes. It brings in the changes from your teammates and it integrates them together. And if Tony Stark modified different lines in this file than Bruce Wayne did, it'll just put it all together. And it all makes sense and it'll do it all automatically. You'll wind up with the file that looks like this, you know, part the red version, part the green version, where there are changes. So that's good. Now there is a case that's less happy. Okay, now, so Git can figure out as long as you're modifying different lines, even if they're in the same file, it's okay, right? It'll put it together for you. But if two people modify the same line, then it can't tell what to do, right? Because it's got two changes to the same line, doesn't know which one you want. So that's called a conflict. You try to minimize getting this. So if you communicate with each other, like Bruce and Tony have decided, hey, you work on this file, I'll work on that file, they minimize the chance of this happening, but still, it happens sometimes. So they've each made changes to these purple lines. And Git is gonna say, I can't figure out what to do. Right? This was changed by Tony, it's also been changed by you, I don't know what you want. Okay, so that's called a conflict. And what Git does when that happens is it says, oh, there was a conflict when you did this pull, and it writes in your working copy what are called conflict markers. So you're going to see basically in the working copy, Batman's working copy, if he looks in, let's say this was in file 1.cpp, he's going to see text that looks like this. Okay, so there's the whole rest of the file. It's a whole bunch of stuff that was already there, it's fine. And then you see this conflict marker. This conflict marker says head, okay, so it's saying this comes from it's basically telling you these are from two different copies of this file. Okay, so one of them is from the remote repository, the head. One of them is from your working copy, the files you were working on. So basically, this is the line that was in Batman's working copy before he did the pull. And it says Batman is the best. And then you see there's this separator, and then it basically shows this is the line that you just brought in from the remote repository. And it says Iron Man is the best. Okay, so basically Git can't tell what to do because it's got two changes, right? Tony changed the remote repository saying he was the best. Batman changed his local file saying he was the best, the same file. All Git can do is say, you got two changes to this line. Here they are. Whoops, sorry. Here they are. You figure out what to do. So the way you resolve this is you go in and you edit this file. So you edit this file, you have to decide what to do. Do you keep one of these lines? Do you keep the other line? Do you change it to something else? And then you get rid of these conflict markers. Okay, these won't compile, they're not source code, so you get rid of all those conflict markers, just delete them. And then you basically have to tell Git that you're done, that you've resolved the conflict so that it knows it's complete. And I'm not going to go through all the steps. There aren't a lot, but basically in the Git quick start, we tell you what to do for this. So whenever you and your teammates are editing the same lines, you make some more work for yourself. You make these conflicts, try to avoid it, talk to each other. But if you do get conflicts, it's not the end of the world. You just have to look at the file, see, okay, who did what do I want to keep? You edit the file, and then you tell Git that you're done. You've resolved the conflicts. Hopefully that's all clear. So. So I've been gradually kind of building up to how does Git really work. So I've been showing you pieces of it, and now this is the full view of everything that's going on in Git. So let's say I'm working with one of the TAs to make some changes. So I have my own local working copy, and I actually have my own local repository. Sarah has her own working copy. These are the files she's just editing, compiling, etc. And she has her own local repo. Okay, what's a local repo? It's on your own machine, and it is a full Git repository. It has all the revisions in it, etc. So we actually each have our own repository. And then there's something called the remote repo. And the remote repo is shared. We both talk to that. So lots of revision control systems actually don't have these local repos. They just have working copies, and they have a remote repo. Okay, so that's pretty common. But Git goes one further and basically has both a remote repo that everybody shares, but also these local repos that are on your own machine. Okay, why did it do this? Git did this for scalability. Basically, most of your work is just done on your working copy, and then when you want to actually commit some files to the repository, it's actually done on your own machine. And you can actually talk to the repository even if you unplug your computer from the network. So Git made these local repositories so people could do most of their work even if they're not connected to a network, and so that if you had thousands of developers all working on a program, most of the interaction with the version control system happened on your own machine because you're talking to your own local repo, and that made Git very scalable, that you could actually have a lot of people working at once. Because there are only a few commands, basically push and pull, that move data between the local repos and the remote repos, okay? So that's the reason Git did this. The reason I'm showing you this is you need to be aware of this so that you type all the commands you need in order to get your changes to your partner. And in this project, the remote repos are basically set up on a shared directory in the UG machines. Okay, so they're all in the UG machines, but basically the remote repos are shared amongst all the team members. How many people have heard of GitHub? Probably most of you. What GitHub is basically a service to host remote repos, okay? And a few GUI tools that are nice. They give you a nice interface to some Git commands. So GitHub is built on top of Git, but it basically means if you don't have to set up your own server if you don't want to, you could host it on GitHub. Don't do that for this course because your project's going to be public and you're going to get pulled into plagiarism meetings, and it won't work with our submission scripts. But basically there's not much different. It's just a way to host the repos. Okay, so let's look at how I do my daily work. So I come in, I want to make a change. I'm going to show you the animation again. So I'm going to change this file. So I just edit it, right? Make some changes, compile, test, work normally. When I'm happy with it, I actually have to tell Git that I've got some changes. I do that with the command called add. So add is basically gathering together changes. I can run add many times on many files. And it says these are all the things that are actually ready to go, ready to put in the repo. And then I run this commit command. And the commit command puts it in my local repository. So you see the local repo now has a new revision that has this red file in it. If I want to send it to the remote repo, which I usually do, I want to push it. So the push command takes everything that's in all the changes in the local repo and moves them up to the remote repo. Okay, so now my changes are available in this shared remote repo. Okay, so Sarah is working away. If you want to ask Git what changes have been made in my working files, so I've been editing these files, I'd like to know what's been changed, what have I said, what have I used git add to say is ready to be committed? If you want to know basically the status of your project, you type git status. It's another git command. An important thing to know is that git status only talks to the local repo. That's a design decision in Git. In Git, almost everything just works with the local repo. And again, that's to make it highly scalable and so that people can work even if they unplug the network. Okay, so if Sarah does this git status, is she going to know that I've made some changes to my repo and to the remote repo? Like, will she know that I've made some changes? What do you think, given what I've drawn here? So I see people shaking their heads. Yeah, she won't know. Git status will say, well, you have no changes, and actually I don't see any changes that anybody else has done either, so it all looks good. Often students are confused by this, because their teammate says, I did make some changes, why can't you see them? She can't see them because she's only talking to her local repo. So what she has to do to get the changes from her teammate, me, is, let's say she's got a change here, okay, so she's made a change in that file. She can add that and then commit it. It goes into her remote repo, or sorry, local repo. But now, when she tries to do a push, it's going to fail. Okay, the push is going to fail because it's going to say, wait a second, you've got changes, they're based on a certain revision, and that's not the latest revision in the remote repo. So you're going to get that can't do fast forward merge. So, and again, students are often surprised by this because they say, well, I did a git status and it said there were no changes. It's because the git status is only talking to this local repo. Okay, so the push fails. It's okay, it's not a problem. It just tells you there are some changes in the remote repo. That means Git wants you to get those changes, get them into your repo, get them into your working copy, make sure everything works together, and then you can try again. So what command do you think Sarah should type? See if anybody knows this. Buzz in if you know what command she should type. You only have to apply what I told you 5 slides ago. Yeah, so actually C03, let's give you a chance. What should Sarah type?
Git pull.
Yeah, so she should do a pull. Okay, so she does a pull. Again, we recommend you use this -r, but you don't have to. If you just do a pull, it basically does something very similar. Okay, pull does 2 things. It's going to update her local repo. Whoops, what happened here? It's going to update her local repo, and it's also going to update her working copy. So we've got this new change, this red file up here that I made. When she does the pull, it comes into her local repo and her working copy. Okay, now what should she do? Well, she should test, right? As soon as I pulled in some code from somebody else, I should immediately check if it works. Okay, once she's built it, she's tested it, it all works. Now she can try the push again, and the push will work. It'll put in her blue file changes, and now the remote repo has the changes from everybody. Does that make sense? Yeah, so let's go to A09. Yes?
So for commit, there's a message that you can also add. Will my partner receive, if they pull the file in the remote repo?
So you're saying, how would I get Sarah's file? Is that what you're asking?
No, I'm asking like if when I commit like changes and I put a message in my commit command, so commit-m, and it goes to the local repo, and then I send it to the remote repo. When my partner like pulls it from the remote repo, will they also receive the message?
Yeah, the message, so the question is, if you should be putting messages in all your commits. As you're doing milestone 0, you'll see that whenever you do a git commit, we want you to type a message. We want you to make those meaningful. Those are stored in the repo along with all the code changes. When Sarah did this, if I go back one, when she did this pull, she got all the changes, she also got all the messages. So she can do anything she wants now. She sees everything. But basically, Git doesn't broadcast stuff. So you don't know that your teammate made a change to the remote repo until you do a pull. Okay, that's what brings the changes from your teammates in. It's not a bad idea to do pulls pretty often, like whenever you are kind of done something. It wouldn't be a distraction to bring somebody's changes in. Okay, so yeah, and what I should do too is now I should do a pull, and I'll get Sarah's changes. Okay, so your coding routine is you do a git pull to get the latest code, you fix a bug, you add a feature, you build it, you test it, maybe you have to try debugging it for a while, but when it works, there's 3 commands. Git add to tell Git there are some changes in this file, I want you to get them ready to commit. Commit to put it in the local repository, and then push to put it in the remote repository. So it's always this sequence. You might do many adds to add a whole bunch of files, that's fine. But then you commit them to get them in the local repository, push them to get into the remote repository. okay? You will sometimes get this failure message saying, I can't do a fast forward merge. If that happens, it means somebody's put something in the remote repo while you were working. Do a git pull again, build it, test it, try the push again. If you've gone off and worked on your other courses for a while, before you start something new, it's a good idea to do a git pull to make sure you got the latest code from everybody. You get that before you start doing edits. Because if you just started editing, there's a chance you edit some lines that one of your teammates edited, and when you do a pull, you get a conflict, and now you got some manual work to say which changes are which. If you just do pull before you start some work, you minimize the chances of that happening. So it's a better practice. Okay, so I'm going to teach you another important Git feature, which you do not have to use in this course, but you're probably going to hear about it. You'll probably use it in your career. So it's called branching. Okay, so let's talk about why would people branch. So let's say Tony Stark's finishing off milestone 1. It's working, he's just fixing a last few bugs. Bruce Wayne is bored, wants to start working on milestone 2. But we don't want him breaking anything because we're about to submit milestone 1. So we're kind of worried if he's making large-scale changes, this might not be the right time to do it. But we'd rather not tell him to go off and just take a vacation for 3 days. So our solution is to branch. So what branch means is we essentially change what part of the repository the two of us are working on. So more specifically, branches are references. They're basically a pointer to a certain commit. And a branch is a pointer to a commit that is called the tip of a branch. It means there's no commit after it. Okay, so by default, in the projects we've set up for you, there's a master branch, and by convention, this is just something people have chosen, the master branch is the most important and longest lived branch. It doesn't have to be, you could call it anything. In fact, some people call it main instead of master. We called it master, so that's the longest lived branch. And again, it's just a pointer. So if I've got all these revisions, showing here 3 different revisions, right now the master pointer points at R101, so the last commit in this chain. So it points at the tip of a branch. There's another important pointer called head. It's a ref, which is Git speak for pointer, and it points to the branch you're working on, okay? So right now, both Tony and Bruce, they each have their own head pointer, and they're both pointing at master, okay? Which itself is just a pointer. It's just saying this branch, this commit. Okay, so normally what happens is as they're working, their commits just keep going in a nice line, okay? So R102 would go here and so on. But I don't want to do that now. I kind of want to have 2 parallel lines of development, one of which is just small changes for milestone 1 and one is bigger changes for milestone 2. So the way we do this is Tony runs this command, git checkout. That's to get a new, basically to get a certain commit into my working copy, and he specifies this -b or branch option, and he gives it a name. So the name he's chosen could be anything, but he's going to call it finish M1. It's for milestone 1. Okay, what did that do? It made a new pointer, okay, a new ref. It's called finish M1. It points at exactly the same revision as the master does right now. They both point here, okay? And Tony's head pointer, which is basically where are my changes going to go, it now points at finish M1. Bruce Wayne still points at master. Okay, so that command, all it did really was create a new pointer and make my, which we call a branch, and make my head pointer point at it to say that's the one I want to work with. Okay, so now what happens after that command is Bruce Wayne didn't type that command. So his head pointer is still pointing at the master. His commits keep going on the master, the long-lived branch. But Tony's commits are now going on this finish M1 branch, okay? So when he commits and pushes, he makes a revision here, which is basically not connected to the revision that Bruce Wayne made, okay? And they can keep working like this for some time, okay? So they keep making commits, and what we have is we have 2 parallel chains of development, right? All Bruce Wayne's changes are going here, all Tony's changes are going there. I can build the finish M1 code. I could also build the master code, but they're a bit different now, right? I've got two different chains of development. So does that make sense? That's how you make branches, so that you can kind of both start working on the source code without interfering with each other. Everybody with me? Okay. Now, what happens often, is that maybe I find a bug, and I'd like to fix it on both of these. Okay? Whoops, this should be called finish M1. So that name is wrong. I'll fix that after. So let's say this revision 106 was a pretty important bug that Tony found and fixed it, and we shouldn't just fix it for milestone 1, it should be fixed in the master code, the long-lived code 2. And he'd rather not do this by hand. I mean, he could go and tell Bruce, hey, I got a bug, here's what it is, go fix it. He'd like to just tell Git, take that commit and get those changes into the master, because it turns out these ones are important. And there's a command for that called git merge. So if he types, what he has to do first is he has to make his head pointer point at the master again. So he does a git checkout master to say, I'm now working on the master, put my commits there. And then he runs this command, git merge and the name of the branch, finish M1. And it basically takes these changes and it will integrate them in a new revision on the master. So now this new revision is actually part of the master branch, and it incorporates everything, right? We have all of Bruce Wayne changes, and we actually now have Tony's changes in as well. Okay, so we can pull changes in from this other branch. Is everybody clear on that? You won't remember probably all these commands. That's why they're here, documented. You'll have to play with these a bit to get comfortable with them. Okay, there's another way to do this. Git has the merge command. It has another one that's closely related called rebase. Okay, so let's say we're in this scenario again of Tony and Bruce have each been working on different branches. And I decided what Tony's done is good. I want to kind of get it onto the main line of development, the master. He can do a rebase as an alternative to git merge. Okay, so what rebase will do is it basically will take these two commits that he did and it'll redo them on the master branch, okay? It gives essentially the same end result in terms of code as git merge, but you'll actually see all the revisions. Like if we actually look at this chain of development, this list of revisions, you'll see all of the changes with all their commit messages. So it looks a bit cleaner in terms of the commit history. But the end result in terms of the code is the same. Okay, so he would do that by typing this, git rebase master, and it basically would make this finish M1. Instead of being based on this older revision, it would now be based on the latest master revision. And so you'd have everything together, but you'd have it together where you can see all the commits in a nice linear order, which looks nicer if you want to look at the history of the project. Okay, so it basically replays the commits that Tony has done, these two commits, on the branch that I specified, which in this case was the master branch. Okay, so I basically updated my finish M1 to incorporate everything, all the commits I made in it and all the commits that have been made in master. Okay, so as I said, it makes the command to actually see the history of commits in a project is called git log, and if you use rebase, git log basically produces easier to understand output, because you kind of see all the commits in a nice order. So that's the plus side. That's why lots of people like rebase. There's a downside. If, let's say, Tony was working away and he'd actually made 15 commits. If you've done a lot of commits on some branch and you use rebase, there's a higher chance of conflicts and more work to resolve them, because basically replaying a whole bunch of commits on top of a master, especially if there were a lot of commits on the master too, there's more chance that replaying those actually produces a bunch of conflicts that you have to resolve than if you just did a merge. So it's not a good idea to let your branches live for a long time if you want to bring them back together again. You should try to bring them back together pretty often. And if you do leave branches around for a long time, then git merge starts becoming a better choice, because rebase can have more trouble resolving conflicts. Okay, Okay, when do you use branches? So we use them for releases. So when I worked at Altera, we would take 3 months to actually stabilize the code before we shipped it out to our customers, because the cost of bugs is very high. They're going to have hardware systems that don't work. Quartus is broken. We don't want to stop everybody from working for 3 months, so we'd branch the code. One part is going to be the new release. The other part is we called it the trunk, but it's basically the same. Trunk or master or main, the thing that keeps living on. So that's a release branch, and the release branches usually live for quite a while because you're going to send them out to your customers. The other reason people use branches are what are called feature branches during development. So a feature branch is you make a branch, you're going to make some new feature, you're going to try to do it relatively fast, and you're going to merge it back into the master branch. Again, if that feature branch lives for a long time, like you're working on that feature branch for a couple weeks, there's more chance that you're going to get conflicts. The longer the two branches are apart, the more chances you can't put everything together cleanly and you will regret it. So if you want to, you can use this flow of creating feature branches in 297, but students often get themselves in trouble because they don't merge often enough. So if you do this, you got to merge or rebase very often. The flow that I showed you where you commit and push and then you pull is effectively it's like you're making really short branches. You're not actually explicitly making a branch, you're reintegrating your changes very often. Probably an even better flow for this course, but your choice. Quick command reference. I'm going to put this up mostly for reference. You use status to ask what's going on, and it talks to your local repo, so it tells you what files you've changed and so on. Git log gives you the history of what's been changed in this repository. Git add prepares some of your files to go into the local repository. So I haven't talked about this, but basically in Git they talk about the staging area. So you have your working directory, which is the files you're compiling. The staging area is things where you've typed git add. So you've said these changes are going to go in the next commit. Git commit. Commit puts things in the local repository. And git push moves them all the way to the remote repository, okay, from your local repository. Git pull is shown here, and git pull basically gets the changes all the way from the local remote repository, puts them in both your working files and the local repo. If you ever decide I just want to see what's in the remote repository, but I don't actually want to change any of the files I'm working on, you can use git fetch. Basically, pull is a combination command. It does a fetch and a merge. And the combination of those bring all the changes to the remote repo into your local repo and update your working copy. If you use the -R option to git pull, you're doing a fetch, and instead of doing a merge, you're doing a rebase. So all it's doing is how it integrates the changes into your working copy is different. As I said, it gives you a nicer revision log. Git log will look nicer, but if you've got a lot of changes that you made and your teammates made, it might give you more conflicts. So in that case, maybe git pull would work better. Okay, Git's big, lots of references. I'm going to leave up these options here. Read the quick start guide for sure, and then there are lots of online guides. My favorite one is this Atlassian one. Okay, with that, I will turn it over to Professor Chong.
Okay, thanks everybody. So we're going to turn our attention now to wd0, the assignment on made to stick, the initial one. And I just want to talk about how this assignment breaks down and how we can use the book itself to understand what we're trying to do in the actual assignment, okay? So there are two key components to this assignment. The first, of course, is the summary of 3 principles that you choose, right? And the second component is the analysis of the presentation using one of those principles. And we're going to get to that probably next class, and today we're going to focus primarily on the idea of the summary of the principle. Now, if you look at the prompt in the assignment, it says essentially, briefly summarize the 3 principles from made to stick, and to paraphrase, explaining the concepts in your own language. What we want to see here is not for you to pull the relevant words from the text, but to actually show in your own words what your understanding of that principle or concept is, okay? One thing you should already know about engineering writing compared to writing English essays is that we very infrequently use direct quotations, right? And why is that? Well, it's because in engineering writing, what is really important is the ideas and not the exact expression of those ideas in the words. Now, this is kind of a mixed assignment. You're kind of looking at a text like an English student maybe might do. So it's kind of mixed, and there may be little snippets or phrases that really capture what the author is trying to say that you may want to use, but you do want to make sure that most of this is going to be couched in your own language. Okay? And with the concept of summary, I think what's really important to note in this particular case is that there's a really close tie to one of the principles that is laid out in Made to Stick. And of course, that is the principle of simplicity, right? A couple of classes ago, I laid out that the idea of simple is actually a little bit more complex than it seems initially, right? So that it's not phrased as compact, short, or easy. That's not the only component of that definition in terms of how Chip and Dan Heath talk about that. If you were to define it as that, you would be missing a really large part of that particular definition, okay? And then we talked about it as being, okay, compact and core. And then I use the phrase, well, as in a proverb, not a soundbite, okay? And that's pulling from the text itself, a little phrase, 5 words, pretty substantive and important in terms of the way that you define it, okay? And it does really kind of capture their definition of what simple is. The problem with this is that in trying to actually explain this or communicate this to somebody, you need to know very clearly what a proverb is and what a soundbite is and what the differences are, okay? So while that short little passage captures the essence of the definition in a metaphor, right? You're given a larger opportunity to explore this idea a little more deeply, and you can push a little further to understand, what a proverb is, how it differentiates from a soundbite. So in your summary, you can go a little bit further than these 5 words. Okay? Now, a proverb, something like a bird in the hand is better than 2 in the bush, right? A soundbite is obviously just something that you hear and you can remember very clearly, okay? So those 2 components. Now, if you look a little bit more closely at the way that they define the idea of simple, and as they move beyond this idea of just a proverb and a soundbite, they really get to kind of explore this idea of the commander's intent. Okay, and this idea from Colonel Kolditz was really about how in battle, and I'm going to use a proverb here, a battle plan doesn't last much longer than first contact with the enemy, right? And you might have a very detailed plan, but what you need underneath this plan is a really good idea of what the core intent of that plan was, because once you are in battle, often those plans kind of go awry, and you have to recall what the core idea of your plan actually was, okay? So in the book, they talk about how finding this core intent is really about stripping the idea down to its most critical essence. So don't worry about each of the stages that you want to be able to complete, but make sure you get to that critical essence, okay? Importantly, they define it as having three things, right? Getting to this idea of this core intention, okay, or core message, okay? Making sure that it's concise, but then also helping us to understand how to act based on this simple or core message, okay? So we see that in a proverb, right? A proverb is a short saying that tells you how to act in certain ways, right? And they're often cross-cultural because they have so much meaning and significance, okay? Now their example, one of the, I think the best example in the book is when they talk about Southwest Airlines, right? And they talk about this idea of, you know, we want to be the low-cost carrier, right? And the example in the book was this idea of, okay, somebody proposed the idea, okay, what if we add Caesar salads, chicken Caesar salads to each of these flights? It'll make a bunch of people happy, it'll improve our food offerings, but really what they use that core intention as, or the commander's intent in Southwest, is to really help determine what course of action they would take. And they ask themselves the question, is adding chicken Caesar going to make Southwest the low-fare airline carrier on that particular route? And of course, the answer is no, right? And so really it's about developing this idea of a core intention that leads to understanding how to act in certain cases, okay? So if that's the way that we define simple, right, and the idea of simplicity, obviously it goes beyond compact, short, or easy, kind of contains a few more components, okay? We can start to look at some examples of how maybe we would write the summary up, okay? This is an example that I'm going to show from a student paper for wd0, okay? And I'll just ask your opinion out there. What do we think of this definition of the simple principle in made to stick, based on what I've just talked about? Give you a second to digest it, and then any takers, hands up or press your mics. I see A09 just itching to touch that remote mic, so I'm going to put your microphone on. Yeah.
I guess there's a lot of reference to terms that the reader might not be aware of, like what stickiness actually refers to, dumbing down, sound bites, like that.
Okay, so it doesn't really give a very direct definition of the principle of simplicity. That's a really good point. It says there's a lot of terms in there that need definition and clarification, okay? So we can look at that first sentence a little carefully because that's where we want to look, where we start, right? And it's not a very sticky introduction, is it? It's not a very useful introduction. It's wordy and it's not very meaningful. Okay, so what does that sentence actually say? Well, I think it just says, and made to stick, simple is the first principle of stickiness. Okay, all right, so we fixed that. We've done one thing. We've made it more concise, okay? But what we haven't done is we haven't really gotten at the core intention or the core message, and we haven't gotten to the idea of action either, right? So it's still not a very sticky introduction, okay? It's less words, but it's not particularly meaningful. Now, is the definition in that particular passage? Can we see where the definition actually is? You're actually still on A09. Oh, sorry. Okay. Where does it show up? C14?
In the last sentence where it says simple is finding the core of the idea.
Yeah, so the definition, the meaningful part of it is actually at the end of that particular paragraph, okay? So the first thing we would want to do if we're trying to be simple, clear, and concise is to pull that to the front, okay? At least you're defining, okay, at this point, in mate to stick, simple is all about finding the core of the idea, okay? So then you can kind of turn it into something that looks like this, okay? As they tell us, this is not simply in terms of dumbing down or sound bites. You don't have to speak in monosyllables to be simple. Okay, now they've chosen a set of direct quotations, right? And they've done it fairly purposefully. Now, here, they've actually misattributed here because, in fact, if you look at the text, okay, this whole passage is from Chip and Dan Heath, okay? So you want to be really careful if you're pulling passages from the book to make sure that you put quotations around it because otherwise it would be an academic offense, okay? But more importantly here, okay, because this is the definition, this doesn't actually speak to the concept or work to explain that concept in the context, right? And so using this particular set of statements and pulling this particular passage from the text isn't helping to define the concept particularly well, okay? So essentially, you want to be really careful what you're pulling to make sure that you're using passages, if you are pulling passages, that actually explain the concept particularly well in this particular context, okay? Now, you would want to pull, for example, and link it to the idea for core intention. So now, once you have this core intention, you can express it concisely without dumbing down or reducing the idea to a soundbite. Okay, that's a little bit better because it's related and linked to that particular concept of finding the core. And then what's still missing here is that we're missing this something about how this leads to stickiness or how it leads to an ability to act on a core idea. So I would probably add a component here that adds, helps people understand how to act or how to prioritize their actions. And then these components are what makes simple messages memorable, because we want to talk about the role of simplicity in the stickiness of messages as well, okay? So now we have a good starting point, right? It's not finished, okay, I don't think. And you want to think about that a little bit further. But remember, what we're really after is not a textbook definition. It's really about what's at the core of your understanding of these principles, okay? And we're looking at the concept of simplicity as key in crafting your own messages, okay? Now, we can start to apply this to the rest of those concepts as well, okay? So we think about unexpected. Okay. It's not just use the element of surprise to get somebody's attention, okay? You'll see the example that they use is the example of the Super Bowl ad where there's a marching band and then wolves run through the field and start tearing people apart, okay? That's a very famous example of an ad that certainly does use the element of surprise, but it doesn't do a very good job of making that message memorable. Okay, and similarly, surprise is not the only thing there, right? And then similarly with the other concepts, it's not about just using concrete examples. It's not just be credible. It's not just use emotions or tell stories, right? In the context of unexpectedness, it's about understanding that audience's expectations about a set of core messages or core message, and to break these expectations in order to get their attention and refine their understanding of the core concept, okay? And I think the best example from the book is that Enclave minivan example, right? Where it looks like it's an ad for a minivan, but halfway through there's an accident and it turns out that the message is really about road safety and driving safety rather than an ad for a minivan. Okay, so as you're thinking about this, you'll want to think more about these questions around what do concrete examples do, how you can create credibility, why and how to make people care, right? And again, this is always going to be related. All of these concepts are going to be related to the core idea and something contrasted against this idea of the curse of knowledge, okay? And as we pick up the idea of analysis,